In the last session of this lecture, we are going to introduce probabilistic hierarchical clustering. What is probabilistic hierarchical clustering? Let's first examine the problems of algorithmic hierarchical clustering. The first problem for algorithmic hierarchical clustering it is non-trivial to choose a good distance measure. For example, we already see the single link, the complete link, the average link, and the centroid link. They are all different methods, but it's hard to choose a good distance measure based on the application problems. The second problem is it is hard to handle missing attribute values, because when the attribute value is missing, it may impact on the quality of clustering. The third one is the optimization goal of algorithmic hierarchical clustering is not so clear because it is a heuristic algorithm. It more relies on local search. Now there's another approach called probabilistic hierarchical clustering. This method essentially uses probabilistic models to measure distance between clusters. It is largely a generative model, means it regards the set of data objects to be clustered as a sample of the underlying data generation mechanism to be analyzed. Then you finally find the parameter, find how they generate this data set. It is easy to understand. It has the same efficiency as algorithmic agglomerative clustering method, and also it can handle partially observed data. In practice, we can assume the generative models adopt common distribution functions. For example, we can assume it's a Gaussian distribution or Bernoulli distribution and governed by a set of parameters. Let's look at the generative model. In the generative model, we can assume given a set of one-dimensional points x, we can assume they are generated by a Gaussian distribution like this. Okay. That means you essentially using different mu and sigma, you may generate the distribution according to the typical normal distribution or Gaussian distribution formula. Okay. Then the probability a single point x sub I, which is one point in the set x, is generated by the model. Essentially is what's the probability to generate x sub I under the condition of mu and sigma is based on this formula. Then for the likelihood, this whole set of x generated essentially is a likelihood for the normal distribution to generate this set of x points. Essentially, it's the probability of a set of points x under the condition of mu and sigma square. For I from 1 to n, all these probability multiplying together, we get the probability to generate the data set x. Then the task of learning this generative model essentially try to find the parameters mu and sigma. So for this particular distribution, we try to find the maximum likelihood this set of x is generated according to these two parameters. So the Gaussian distribution usually, I think most people know, for example, for a beam machine, if you drop the ball with pins, if you use many balls, finally you will find the distribution is Gaussian distribution. Then if we have many points, we can assume these points actually generated by the Gaussian distribution like this. Okay. Actually, for one dimension Gaussian, this different mu, different mean, and different variance, you probably can see they generate different distribution. Okay. For two-dimension Gaussian, it may generate in the 3D space. You probably can clearly see the distribution of these 2D Gaussian. Then a probabilistic hierarchical clustering algorithm essentially is, suppose we already got partition the whole set of points into m clusters, C sub 1 to C sub m. Then the quality of the clustering can be measured using this quality function. That's the product of all those probabilities. Then if we want to merge two clusters, C sub j1 and C sub j2, then the change in quality of the overall clustering is the Wood criterion. Okay. So you probably can see this is the merged cluster. You generate a new cluster, and these original two clusters disappear from the original set of clusters. So that's the new clustering. That's the original clustering. Because you merge this, essentially the sum of the square errors will be increasing. So that's the reason you try to minimize such increasing. That's the probability of PC sub I. Now you get a probability of these two merged together. Okay. Then you have to minus the original probability I from 1 to m. Then the distance between cluster C1 and C2 is, this is the probability of C1 and C2 together as one cluster. These are the independent cluster. If this distance is less than 0, we should merge these two clusters. So that's the idea or the essence of probabilistic hierarchical clustering algorithm. So now we summarize the whole lecture. We introduced hierarchical clustering methods. We first introduced the basic concepts of hierarchical clustering. Then we introduced the agglomerative clustering and divisive clustering. We also studied the extensions to hierarchical clustering. Especially we discussed Birch, Cure, and chameleon algorithms. Finally, we introduced the concepts of probabilistic hierarchical clustering. These are a set of books and papers. For example, these three papers is Birch, Cure, and chameleon. That's the original papers. Most of others are the textbooks discussing different methods and alternatives of hierarchical clustering algorithms. Thank you.